All right, people, we're going to go over this Unit 2 Worksheet 4 as your homework from last night. So, let's see what we can do here. First problem, all these arrows are the same, all right? From the motion map, answer the following. What can you conclude about the motion of the object? One, we can conclude that it's moving. We can say that it's moving to the right, and we can say it's got a constant velocity. What do you think about that? Draw a qualitative graph for this. Okay. Now, if this is x and this is t, a qualitative graph will be a straight line. Okay? Because all of these arrows are the same. All right? And since all these arrows are the same, that means the slope of this line will be the same the whole time. Does that make sense? Now, if you saw a graph that looked like this, which we may get to by the end of class today, if you saw a graph that was curved, that would indicate to you that the object was accelerating. But this straight line shows you a constant velocity. Does that make sense? All right. And let's see, what was the next question? I wish I had a marker that was working better. That's my fault. Draw a qualitative graph of V over T. Okay, excellent. So you can't see as much on the video, but I'm sure they can see at home. This line in the middle is bold. So this line in the middle, if this is V, this line in the middle is 0, down here is negative, down here is positive. So we're going to just say, you just draw a line up here anywhere that's straight, that's a constant velocity. Is everybody with me? Now, if we were going to make it qualitative, we could say 1 meter per second, 2 meters per second, 3 meters per second. Right? All right, let's keep rolling. Write a mathematical expression that expresses the relationship between distance and time, or between x and t. We did this yesterday. I feel like we covered it. V is equal to d over t. Write a mathematical expression that represents the relationship between v and t. Okay, so if we're solving for d, then d is equal to v times t. Does that make sense? The distance you go is equal to the velocity you're going times that time. Describe what the area under the curve in figure 2 represents. Area under the curve in figure 2. Okay, well, it's not a curve, but they're calling just the line that you made on the graph, they're calling that the curve. Okay? So, if you have a velocity over time graph, and you look, if this is velocity, and then the x here is time, we talked about this yesterday, the area under the curve is equal to the what? Can anybody remember? It's the distance you've traveled. That's exactly right. Boom, smoking it, smoking it. All right. Now, from the position on this table, answer the following questions. All right. Now, construct a graph. Okay, here's what I'm going to do. I'm going to go up here. I'm going to lock this in. Freeze. Then we'll go back so I can read the numbers. All right, so time and distance, 0, 0. So here we go. If I got 0, have I done a poor job of freezing this graph? Or the graph is missing. Okay. I'll do my best. Kids at home and people in here, it looks to me like when I transferred this graph from a Word document to a Google document, that part of the graph got cut off. Does that make sense? Darius, you know what I'm talking about, brother? Yeah. Yeah, this should go down to 0. So I think something happened when we converted it from a Word doc to a Google doc. Basically, all I was going to do is plot the numbers on this graph, but it's kind of messed up. I'll try to get up here where we are and say 3, 4, 5. So if this is 3, 4, 5, 6, 7, 8, 9, 10, I can at least graph anything. So if we have 2, 6, 3, so 2 and 4, right? and this is our time, okay? So 1, 2, and 4. And then we're out at 3 and 4. And then 4 and 7. 4 and 7. And then 5 and 10. 5 and 10. Does everybody see what I'm doing? And then 6 and 10. Then 7 and 10. Then 8 and 5. And then 9 and 0. So what you end up with is in the middle of this graph, you have this shape like this. And then it looks like it keeps going on after that. I can't put the bottom of the graph on here because it's broken. But you should understand what I've gotten here so far, right? So we could talk about this car, we could look at it, we could think about what's happening. If this is your distance, you can see that what do the slopes of these lines represent? The slope of the line represents the velocity. Does that make sense? And you can see at these points where it stays 10 meters away for 3 seconds, right here the car is stopped. Right here the slope is negative, so the car is returning or coming back. Does that make sense to everybody? All right, and since these graphs are messed up, I'm not going to really graph the rest of this. Yeah, since the graph is messed up, I'm not going to do any more work on this one. So there's your best review I can give you so far.